Hello viewers, in today's class we are going to discuss one important and conceptual problem from limits, right? And here we have to find the value of this limit, that is limit x tends to 1 minus, and we have a sign of a mod of greatest integer of x minus 1 divided by a mod of cos of greatest integer of x minus 1, right? So here we have to find the limit of this function when x tends to 1 from the left of x is equal to 1, right? So it implies that we have to find the value of the limit of this function when x approaches to 1 from the left of x is equal to 1. So now here we observe that we have the mod function as well as the greatest integer function, right? So now let us take this limit as L, right? So here what we will do, we'll take x is equal to 1 minus h, right? So here we have x is equal to 1, and we have to find the left hand limit of this function when x approaches to 1, right? So here x approaches to 1 from the left of x is equal to 1, and here in the neighborhood of x is equal to 1 we have the point 1 minus h, right? And when x tends to 1 then obviously h tends to 0, right? And here this quantity h is a positive quantity, and it is a very small quantity, and it lies between 0 and 1, right? So now let us transform this limit L in terms of h by taking this substitution, that is x is equal to 1 minus h, right? So now this limit L can be written as the limit, and here we have h tends to 0 because when x tends to 1 h tends to 0, and here we have a sign of greatest integer of x minus 1, and we can now write greatest integer of x. Here we have 1 minus h, and here we have minus 1, and this is the mod sign, and in the denominator we have mod of cos of greatest integer of 1 minus h minus 1, right? Okay, so now we'll simplify this expression. So we have limit h tends to 0, and here minus 1 and 1 get cancelled, so we are now left with the sign of mod of greatest integer of minus h, right? And in the denominator we have a mod of cos of greatest integer of minus h, right? Okay, so now we have obtained this expression, and here we cannot directly substitute h is equal to 0, right? So for assigning the value of greatest integer of minus h, what we will do, we'll take help of this inequality, right? So this inequality says that h is a very small quantity, but it lies between 0 and 1, and moreover h is positive. So now let us take this inequality. So here we have h lying between 0 and 1, and we need to find out the value of greatest integer of minus h, right? Because here in the numerator and denominator we have greatest integer of minus h. So what we will do, we'll multiply this inequality throughout by minus 1, right? So once we multiply this inequality by minus 1, the direction of the inequality get reversed. So here we have 0, and here we have minus h, and here we have minus 1, right? So now this inequality can also be written as minus 1 less than minus h, and this is less than 0, right? So this is also a very important inequality, right? And this inequality suggests that this negative h, it lies between 0 and minus 1, right? So once we have established that minus h lies between -1 and 0, so by definition of greatest integer function, the value of greatest integer of minus h must be equal to -1. So this is a very important result. So now the value of greatest integer of minus h is equal to -1. So now this limit can be written as the limit h tends to 0, and here we have sign of mod of -1, right? Because greatest integer of minus h is equal to -1, right? And in the denominator we have mod of cos of -1, and now we'll make use of an important result from trigonometry, that is the cos of minus theta is equal to a positive cos theta, right? So cos of -1 is equal to cos of 1, right? So now this limit L can be written as the limit h tends to 0, and here we have sine of mod of -1, that is simply equal to sine of 1, because mod of -1 is equal to a positive 1, right? And cos of -1 is equal to cos of 1, so we have mod of cos of 1, right? And mod of cos of 1 is equal to cos of 1, right? So now since this expression is now independent of h, so we can now remove this limit notation. So we can now write this limit L as sine 1 divided by cosine of 1, that is equal to tangent of 1, because tan theta is equal to sine theta over cosine of theta, and when we take theta is equal to 1, we get tan of 1 is equal to sine of 1 over cosine of 1, right? So the value of this limit L is equal to tangent of 1, right? So viewers, this is how we can solve these type of limits.